In this video, we're going to learn how to create an equilateral triangle. To do this, we're going to follow a set of directions that was actually written over 3,000 years ago by a man named Euclid. We're going to follow the directions step by step, reading very carefully and completing each step as we go. It's very important that we take our time when we read directions like this and make sure we understand what it's saying. So we're going to start with the first sentence. It says, let AB be the given finite straight line. That means we're going to have a finite straight line. Finite, if you remember, means it's going to end. So what we're going to have is a line segment. The endpoints on the line segment is going to be point A and point B. So I'm going to go ahead and draw a line segment. It doesn't give any kind of length for our line segment, so it can be any size we want. Okay, there's my line segment. Now I'm going to go ahead and label the endpoints A and B. Alright, next step says, so it is required to construct an equilateral triangle on the straight line AB. That's just Euclid's way of explaining what these directions are doing. It's saying we're going to construct an equilateral triangle. It's going to be on the straight line AB that we just drew. That means A and B are going to be one of the sides of the triangle. So line segment AB is going to be one of the sides on the triangle. Next sentence is really long, so I'm actually going to break it into several parts and do each part before I move on. First part says, let the circle BCD with center A and radius AB have been drawn. So we're going to make a circle. It's going to be circle BCD. That means that on the circle are going to be 3 points, point B, point C, and point D. If we look, we already have a point B, so point B is going to be one of the points on the circle. If we also look, it says centered on A. So it's going to be center is going to be A. The radius is going to be the line segment AB. So we're going to draw a circle. Our circle is going to have center on A, and the radius is going to be AB. I'll go ahead and draw that. Okay, there we go. So we have a circle centered on A. The radius is from A to B. Now remember, radius means that any point from A to the circle is going to be the same size, and the size is going to be the length of line segment AB that we drew earlier. Alright, let's go on to the next step. The next step says, and again, let the circle ACE with center B and radius BA have been drawn. So we're going to draw another circle. This one's going to be centered on B this time, with line segment BA being the radius. So let's think about that for a minute. That means basically it's going to be the identical size as our first circle, only this time it's going to be centered on B. So we'll go ahead and we'll draw another circle centered on B. Okay, there's my second circle. When I have it centered on B, it has a radius of the same size as a circle that was centered on A. So basically we have two identical circles, one centered on B, one centered on A. Let's move on to the next sentence. Next sentence says, and let the straight lines CA and CB have been joined from the point C, where the circles cut one another, to the points A and B respectively. Alright, let's think about what that says. We're going to have two straight lines, CA and CB. They're going to be joined from point C. We have not put point C on our circles yet because I wasn't sure where it's going to go. Now I am sure because it says where it's going to go. It's going to go where the circles cut one another. We have two choices for that. We have one place up on top where they cut one another, where the two circles intersect, and we have one point down on the bottom where the two circles intersect. We can use either one. So let's go ahead and use the one on the top. So we're going to put a point C on the top where the two circles intersect each other or cut one another. Then we're going to draw two lines. One line from point C to point A, one line from point C to point B. So I'll go ahead and do that. Okay, there's my two lines. I have one line from C to A and one line from C to B. And actually, we're pretty much done. Our triangle is right here in the middle of our drawing. And it is an equilateral triangle, but we just can't assume that. And Euclid realized that, so the rest of his directions are actually proving that the triangle that we just created is in fact an equilateral triangle. So let's go through that step by step and think about why what we just did is an equilateral triangle. So the first part says, and since the point A is the center of the circle CDB, AC is equal to AB. So that means that since A is the center of circle CDB, and I haven't put point D or point E on there yet, so I'm going to go ahead and do that real quick. It didn't say where to put it, so you can put those points anywhere on the circle. So let's go ahead and put point D right here, and point E over here. Okay, so we're saying that AC is equal to AB. Why? Well, because they're both radiuses of the same circle. Remember, radius is the same for any part of the circle. So AC is equal to AB. Let me go ahead and write that down. Yep. Line segment AC is equal to line segment AB. Alright, next part of Euclid's proof says, and again, since the point B is the center of the circle CAE, BC is equal to BA. So it's for the same reason. They're both radiuses of the circle centered on B. So, and radiuses are equal to one another if they have the same circle. So we have BA is equal to BC. Okay, look at what we just got done writing. We have line segment BA over here, and we have line segment AB up here. Those are both the same line segment. It's just written differently from a different direction. So they have the same size. We're going to use that in a minute for the rest of the proof. Alright, next part says, but CA was also shown to be equal to AB. So we have CA is equal to AB. And it's the same reason. We have AC up here is equal to AB. So if you write it differently or backwards, CA is equal to AB. I'll go ahead and write that down. So we have CA equal to AB. Next part says, thus CA and CB are each equal to AB. So CA and CB are each equal to AB. Okay, so think about that for a minute. We're saying BA is equal to BC. Okay, it's another way of writing CB is equal to AB. Then we have CA is equal to AB. Okay, so what it's saying is all these different sides are equal to each other. It says, but things equal to the same thing are also equal to one another. Thus, CA is also equal to CB. And it goes on and says, thus the three straight lines CA, AB, and BC are equal to one another. So they're saying all three of these line segments are equal to one another, making an equilateral triangle. The end of this proof says, thus the triangle ABC is equilateral and has been constructed on the given finite straight line AB, which is the very thing it was required to do.